What do you mean by an object? So we were discussing the student class, right? And student class, right? It is having uh, say two members, right? One is the name of the student, and another one is the grade of the student. Okay. So when the program begins, right? Let us assume that whatever the marks that you are passing to the student class, right, to the constructor of this student, right? So that we will assign it in the grade. And once, right, you execute this calculate grade. Okay. So this is going to check, right, whether the marks is greater than 90. If it is greater than 90, it is going to assign a grade. If it is greater than 80, it is going to assign a B grade. And if the marks is lesser than 80, then it is going to assign a C grade. Okay. So this is the idea, and this is the constructor. So how you write a constructor? You have to place a double underscore. You need double underscore. Similarly, right, this is so what will happen if I print the object? Okay, so in order to define, right, what is to be printed when you print the object, we have to define double underscore str double underscore. So this is we have, and when we try to create an object for this particular class, so we can say this is the name that we pass and this is the marks obtained by the student, and then, right, you can print and see, right, whether is it correctly assigned, and we are getting the member variable values. Okay. And similarly, right, here, right, we are not defining any marks for Bob. So what will happen if I don't define any marks for Bob? So we have defined a default value of 0 for this grade, and as a result, right, grade will be set as 0. Okay. So if it is not defined, right, then default value will be used. Okay. And this is a check to check whether suppose the user has entered 110, right? So the marks, it has to be limited to 100. So if the user has entered 110, so we are resetting that mark to 100. Okay. So this is a simple check we have. Okay. And so this is right. So how we define one object S1. So this object, it is corresponding to Ajay, and this object S2, it is corresponding to Bob, and S3, it is corresponding to Donald. Okay, and the marks obtained by S1, right? Ajay is 92, Bob is 0, and then for Donald, the marks obtained is 86. Now, if you go and calculate what is the grade obtained by S1, S2, and S3, right? So for Ajay, the grade is 92, right? So 92, the corresponding letter grade will be A. Okay, and for 0, right, the corresponding letter grade should be C, and for 86, the corresponding letter grade should be P. Okay, so these, right, whenever you are calculating grades, you got to use a elif statement, right? So otherwise, right, it will execute this as well as this. So when you use an else if statement, once this path is getting executed, the other paths will get nullified. The other paths, right, will not be executed. Okay, so once one path is been taken, we have to avoid taking the other paths. So that is like a switch case. So that is the reason, right, why we are having a if, elif, and else statements here, whenever we are calculating the grade. So when I run this program, so now we have, so this is right after right initializing the object with the corresponding values, and then we are printing the object. So I'm getting Ajay, and then the grade is 92. For Bob, the grade is 0. For Donald, the grade is 86, right? And if you see after calculating the grade, so we are calculating the grade. So the grade calculated for S1 is A. So grade calculated for S2 is C, right, for 0. And for S3, right, 86, the grade calculated is B. Okay, so this is a simple example, right, that we have seen. Now, instead of, right, suppose, so the main objective of having a class is we have some group of real world objects that we want to represent and manipulate. Okay, so we have defined a class. So we are going for defining a class. So whenever there is a notion of class, right, we want to define multiple objects for that class, and there is no point in having, right, different variables for every time you create an object, you have to assign a different variable name, and then, right, uh, take your class itself. Okay, so your class, right, it may have 60 to 70 students, right, and there is no point in having, right, 70 variables, 70 objects, right, that are defined here, right, each are having individual variable name. So that is not possible, right? So what we can do is we can make use of array of object, right? So in C++, right, what you do is you create an array, and we create, right, something like the class object name is equal to the array. You define it as an array, so which will make it as an array of object. So similarly here, what do you mean by an array here? Here we are not having any array. So the data structure that is corresponding to the array is the list data structure. So we can create a list of objects here. Okay. So instead of having S1, S2, S3, we can create a list, and then write, once it has been created, we can add the student to the list. Okay. So here, right, we have 3 students. So I can create a list of 3 students. Okay. So we will see, right, how to do that. So the same thing, right? Here we are having a list has been defined, and then, right, once S1 has been created, and S1, right, it has been added to this list. Okay. Similarly, right, once S2 has been created, S2 has been added to this list. So this is the list, right? In this list, you add, right, as soon as you create an object, you add it to this list. So this is making, right, list one is the list of objects, list of student objects. What kind of objects? List of student objects. Okay. So now, right, if you go and print what are the contents of the list, it will show your S1 and S2, right? And if you want, right, to parse the individual items in the object. Okay. So let us go up to this and then see what is the output, and then we will come to the last one. Okay. Now I'm printing this. If you see, so it is creating, right? So what is this output, right? You need to know, right, how to interpret this, right? So for printing that list, right, I am printing it as list contents. Okay. This is the list contents we have. Now, what has been, see, what is the content of the list? The content of the list is you are appending the object as such, right, inside the list. And every object that has been created, it is having a unique identifier. Okay. So if you see, right, this object, the object 1, that is corresponding to S1, it is stored at this memory location. And the object 2, right, so which is S2, so that is stored at this particular memory location. Okay. So we are having the S1 object, right, inside the list as the first element, and as the second element we are having the S2 object. Okay. But when you are going and printing the content of the list, it will show like in a unreadable format like this, right? So for example, so instead of, right, printing it like this, right, if I want to know what exactly are the contents of the list, then, right, I can use a for statement, right? Just how you parse the contents of a list. So you say for every item that is present in the list, right, we can go and print the item. Okay. Now what will happen if I go and print the item? Now if I go and print the item, it is the item number 1, right? The first item, it is S1. The second item, it is S2. So when you say print of item, right, now this statement will turn as print of S1 and print of S2. So what is corresponding to print of S1? So it will go, right, it will go to the class. So this is S1 as a object of student. So it will go to the class student, and in the student class, it will go and search whether you have defined str function, right? So if you have defined, see here we have defined an str function. So since we have defined an str function, it will go and execute that function. So as a result, right, we will be getting the name and grade of that particular object, okay, that particular student object. So similarly, right, the same thing will happen for printf S2 also. So S2 is also a student object. So it will go and search whether there is a class called as student, and inside that class, right, it will search for a method called as str, and it will execute whatever the statement that is present here. Okay. So this lets, right, how the Python interpreter knows what is the data type of this individual items that are present in the list, right, and then how it is executing the corresponding print statement. Okay. So that is a beauty, right, of every programming language, right? So here, right, we haven't calculated. If you see the content of the list, now let us comment this. So if you see the content of the list, so this is, right, list contents, we are getting it here, and this is the individual items, right, the values that are present in individual item. So here we are getting name Ajay, grade 100, name Bob, grade 82. So how we are getting this? Here we are having print of S1 and print of S2. So two objects are present in the list. So the first item, right, S1, we will be having print of S1, and for the second item, right, S2, we will be having print of S2. And as a result, right, we are getting the output that is defined in whatever the output, right, that you have defined in str function. So the whatever is present here in the str function, we are printing the name and grade. So that is what we got here. the name and then grade. Okay. So this is how, right, you define list of objects, right, and then you manipulate them. So if you see, right, we have created the student object, and here also we have created the student object, and without even calculating the letter grade, we have appended it to the list. Okay. So here again, right, we have created the student object, which will invoke only the constructor. Okay. So whenever, right, you are creating an object, if the constructor is defined, it will invoke the constructor and it will initialize the class member. So here we are having two class members. So we are not having any explicit class member declaration in Python. So we are going to define the class members as and when required. So here, right, when we go to the constructor, we are passing name and as well as grade. So we will assign to the class, right, we will assign a class member called as name and a class member called as grade. That is the reason why you're having self.name and self.grade here. So for every object that has been an instance of this class, we will define a class member called as name and a class member called as grade. Okay. So this is right. So suppose, right, if you want to calculate the grade and then you print the result, so you can go and say, right, let me make it one more time, right? So for I, say in list one, right? And then, right, you calculate the grade. Okay. And then, right, you say, right, what is the grade? Okay. So we can say print item. Say if you want to get, let us say, I want to get only the name of the student, right? Rather than using the str function to print the entire object, right? Entire object class member values. Let us say, right, you define another, right, a get function, right, which will give us only the name. Okay, so you can define something like this. Okay, define get name. So this will return the name that we have here. So if you see here, right, I need the name and name, right, I can't, this is the actual statement that I have to write. But in Python, right, the default argument, it is self. Okay, so you define a self here and then you say here self.name. So that, right, with respect to which object that has been passed, which object you are calling this method, so that object will be passed here and the name that is present in that object will be returned as a value. So here, right, you can go and say item dot get name. So now, right, we will get the name of the student here. If you want, right, you can merge them into both into a single print statement like this. So this is the first one will print the name of the student, and second one, right, it will print the letter grade. If you see here for Bob, okay, now this is I. So I dot get name. Already here, I dot get name. So now, right, so we got the answer. So this, right, this particular parsing, the objects that are present in the list, this will print the objects, right, the values that are present in that object as such. So here we are getting name Ajay and grade 100 and name Bob and grade 82 as that is defined in str function. Whereas, right, if you go here, so we have defined a function called as get name. So here we have defined a function called as get name, a member function, which will get the name of the student. So for the first object, that is present in this list, we will execute the get name. So it will return Ajay, and then, right, we will calculate the grade and we will return it there. Okay. So the corresponding grade for Ajay is A, and for the second element, right, you get the name of the student. So that is Bob, right, and then you calculate the grade and you print it here. Okay. Now one thing, right, that you want to observe is we are not having, right, we are not, right, after calculating the grade we are not storing it. See here, this function is only returning the value. We are not going and modifying, right, the grade of the student. So this is how, right, you create a list of objects. Any doubts you have? Okay, now the same thing, right, we are going to we are going to introduce one more variable to this existing class, so that it will be more clear. And another improvement that you can make is, instead of passing the values directly, Ajay 100, Bob 82, we can get it from the user, and then you can create a list of objects, right? So that we can do. So this is okay. So this is the same class. So see here, it is the same class. We are having an instructor, we are having a constructor here, and we are having a str function here, and then here we are having a grade calculation function, right? We have created a list of objects, right? It is initialized as empty, okay, which is used to hold the list of objects, and then we are going to get the values of each and every student from the user. So let us so to start with, either you can ask the user, how many students you want to enter the data, and then based on that you can create a while loop and execute it for that much number of times. That is one way. Another way is rather than priorly telling how many students are there in a class, the user can just go ahead and add the student one by one. If the user doesn't have any more student to add, then the process stops. Okay, so this is here we are prompting the user whether he wants to enter the next student's record, right? So that we will get it as like a choice. Okay, so if you take the statement, so here we are asking the student, we are asking the user, whether you want to enter the next record. If the user wants to enter the next record, he will type y. Okay, if the user doesn't want to enter the next record, he will type it as n. Okay, so here we are passing a message to the user stating that you type y for next record. If you want to enter the next record, you type y. If you want to end the process, end the input process, then you type it as n. Okay, now what will happen, if the user enters y, so we are having a variable, whatever the user enters here, that we are storing it in get next. So when you are coming to this while loop, you check whether this get next is equal to y. If it is equal to y, that means that the user is interested in entering the next student record. So you go and get the name of the student, you go and get the grade of the student, right? And then you create the object, right? So see here, so this is the object, st is the object that we are creating. So that will that is an instance of student class, and we are passing the name and grade that we have obtained from the user. Okay, so now st will be created with the name that the user has entered, st will be created with the grade that the user has entered, right? And once it is been created, to this list we are adding the st. We are just appending the st at the end of the list. Okay, so now now it is like you get the name of the first student, get the grade of the first student, right? Check, ask the user, whether he wants to enter the next record, store it in get next. After getting the name and grade of the student, so let us keep this as the last statement here, right? So after getting the name and grade of the student, you create the instance of the student object, you create the student object, and then you append it to the list, you add it to the list. Okay, and once it has been done, so now we have created one object, and ask the user whether he wants to enter the next student record and create the next object. So if the user enters as y, then he is interested in entering the next student record. If he enters as n, then he is not interested, right? So we are going to end this while loop. So if the user enters anything other than y, this while loop is going to get terminated, right? So it is going to get out of this, right? The condition is going to become false. If the user enters as y as n instead of y, then here we will get next is equal to y, that will become false, and it will come out of this while loop. Okay, so it is coming out of this, and here we are passing every item that is present in the list. We are printing the item and we are printing the corresponding grade. Okay, so this is these things are the same as the previous program. Similarly here also, these things are same as previous program. We haven't done any modification to this. Okay, so only thing is we are getting the input from the user one by one, and then we are creating the student object and adding it to the list. Okay, and if you see here st, when the user enters the first record, st will point to the first record. Okay, the object will be created, and st will point to that record. For the next time, you are entering a different name and different grade, st will point to the a different object, right? So next time you are creating a instance of student, this is totally a different object than the one that you have created for the first time. Okay, let us execute this program. So it is asking to enter the name of the student. I am entering it as Alice. The grade of the student, let us enter the marks as 90. Okay, now it is asking me to enter type Y for the next record or N for end. Okay, so let us enter another record. Say I'm typing it as Y. So now the while loop continues and it is asking to enter one more student's record. Okay, so if you see here, so now the while loop is, so this is the get next value. This Y is the get next value. So now, right, we have entered Y for get next. So when it is coming to the next iteration of while loop, it will go and check whether it is equal to Y. Yes, it is equal to Y. So it is going and asking, right, enter the name of the student again. So again, we are entering the name of the student. So I'm entering Bob, right? And then the grade of the student, let us enter as 89. Now, right, now the next statement is student object will be created and it will be added to the list, right? And again, right, it will ask for whether you want to enter for the next record. So type Y for the next record or N for N. So I'm entering, right, say N. So that means, right, get next value will be equal to this N. And when it comes to the next iteration of Y, get next, right, it will be assigned as N. So N is equal to Y. Condition is becoming false, so it will come out of this while loop and it will start printing the objects that you have stored in this list. Okay, here we have two objects, Alice and Bob. So both the objects data will be printed and letter grade, right, it will be calculated and printed. See here, so both the objects, right, so this is corresponding to str function. Both the objects are getting printed and this is the letter grade that is corresponding calculated for each object. Okay, so this is how, right, you get the user input from the user input of many student records, and then, right, you store it in the list of objects. So any doubts in this program? So this is, right, an improvement, right, that we have done for the original student class. Okay, so there are actually, right, different, right, object oriented concepts we have, right, and one concept, right, that we have seen is encapsulation. So encapsulation is binding the data member and the methods that are accessing the data member together into a concept called as class. Okay, so only by using these methods, we will be able to go and modify the values that are present in name and grade of each and every object. Okay, so that is encapsulation, right? And another concept, right, so if you want to know, right, what exactly, because, right, object oriented programming is it is actually taking the concepts that are present in the real world and then modeling it as a program. Okay, so if you are interested in knowing, right, the different examples, the real world examples for every object oriented concept we have, like your inheritance, polymorphism, encapsulation, right, overriding, right, so you can refer to this book. So this book is it is this book, right, it is for C++. Okay, but, right, the first chapter, it is written as very generic, right, which will define to uh, so which is generic, right, which is applicable for any programming language. Okay, so there is a book that is written by Robert Lafour, right, C++. You search for Robert Lafour C++, right, and you refer to the first chapter. I'll show the contents of this book. So if you see here, there is a chapter, right, called as big picture. Okay, so you go through the chapter and there, right, you will understand, right, what are all the object oriented concepts, right, we have. Okay, so this is a very good introduction of this. And another book that you can see is Mastering C++ by Venugopal, K.R. Venugopal. Okay, so that is also right, a very good book, right, which speaks about the different object-oriented concepts. Now coming to Python, right? So let us see the next object-oriented concept, which is called as inheritance, right? So what is an inheritance is, so we are defining a class. So how a class has been defined by, so if you want to represent a common information, right, about say 100 students in a class, or then the 100 students, right, they will have every student, right, they will have some properties which are common to everyone, and they will have properties which are specific to everyone. Okay, and whatever the properties that are common to everyone, so that we create it as a base class. Okay, and suppose, right, if you want to create a particular data member which is specific to a subset of those students, then you define another class. Okay, so for example, right, a simple example is, imagine that this student is a GCT student, and then right now you are having two classes, right? We are having a very generic class called as GCT student, and if you go right, uh, so one thing, right, go and define a class called as person, right? If you want to be very specific, right? So even right, more generalized of thing is a person. So every person, right, he is going to have a name, okay? And let us say he is going to have an address, right, a residential address, and then right from a person. So person, it may refer to an employee, it may refer to a student, right? So it may refer to any person present in the world, right? And from student, right, from person, I can define a class called as student, right? So this is a subclass of, right, so this is a subclass of student. There are a group of persons who are called as students, right? For example, you take the case of a teacher. A teacher, right, once upon see, a teacher is also a person, right? If you see a teacher is also a person, right? So he is also a person. If you see a student is also a person, also a person. Okay. Now imagine that, right, every teacher, right, if you see every teacher is once upon a time he is also a student, right? So when he was acting as a student, there will be some specific properties, right? There will be some specific attributes that he will inherit. For example, right, every student, right, he will have what is the degree that he is studying, right? And let us say, right, what is the percentage of marks he has obtained in the degree, right? And in which college, right, he has studied that degree, right? So these are the data, right, that will be available when you treat a person as a student. Okay, and if you see a teacher was once upon a time he is a student, then that means that when he was a student, he will have these data, what is the degree that he has studied, and the percentage of marks he has obtained, and which college he has studied. Okay, so that's the from the person class, right, you can define a class called as student, you can define a class called as teacher. Now this person is a very generic class which will refer to all the persons in the world, and when you go for this student, it also refers to all the students, right? It is a very generic name that we are giving to all the students that are available in the world. Okay, so it may refer to a student who is studying in India, it may refer to a student who is studying in UK, right? So it is whenever you're defining a class called a student, right, it is a very generic a class, right, which is applicable for every student, right, that is present. Okay, similarly, right, you define a class called as teacher. So this teacher, right, so if it is a teacher, right, so he is also a person, so he will also have a name and he will also have an address, but in addition he will have some other attributes. And what are those attributes, right? So he will have so what is the subject he is teaching, what is the course he is teaching. Okay, let us say, right, how many in which year he has taught this particular subject, and what is the pass percentage in that subject. Okay, and what about his research, what research articles he has written, right? What are the books that he has written? So these are, right, the data that is very specific to teacher. Okay, So if you see, right, from a person class, we are defining two classes. One is a student class, and another one is a teacher class. A student is also a person. A teacher is also a person. In addition to student, right, in addition to having name and address, now, right, we are adding few more attributes to student class, that is degree, percentage, and college. And a teacher, he is also a person, right? So in addition to having name and address for that person or the teacher, we will also define few more attributes like course, year, pass percentage, research, and books. Okay, and in which college, right, he is working. Now if you see the college attribute, now the student class, right, when you refer to this college, now it means that, right, that student in which college he is studying. Now if you go for teacher, right, if you see what is the college attribute, right, and it may refer to in which college he is working, in which college he is presently working. Okay, so it is how you interpret the values that are present in different data members. Okay, so if the same data member, it is present in both the subclasses. So this is a subclass, right? So it is a person, it is coming from person. So this is a subclass. Student is a subclass of person. Similarly, right, a teacher is also a subclass of person. So every subclasses, if you see every subclass, it will inherit all the properties that are present in the main class. So the main class is person. Whatever the data members that are present here, whatever the member functions that are present here, for example, say get name, right, get address, okay, and then right set name, right, set address. All these data members, they will be inherited. So they will be right. They will be copied as such to the subclass. So all these, right, they will be copied as such to the subclass. So now, right, there is no need to define all these data members and functions once again in each subclass. So by when you say, right, inherit, it means, right, whatever the data members that are present here, whatever the properties that are applicable to that person, whatever the behavior that is applicable to that person, it is also applicable to the student. Okay, and similarly, right, whatever the properties and behavior applicable to person, that is also applicable to teacher, because teacher is also a person, student is also a person. In addition, we will be having a few more attributes and few more methods. So similarly, right, here again we will be having few more attributes and few more methods. Okay, so this is a superclass and subclass relationship. Okay, so the superclass is person, and the subclass is, we have student and teacher. Now, right, let us see, right, uh, so one more hierarchy that we can have is, so from person we are defining a class called as student, and from student, right, I can define a class called as GCT student. Okay, now GCT student is a student. Now when you have a class called a student and you are creating an object for the student, right, so it is referring to the generic properties of any student available in the world. But when you are going and defining a class called a GCT student, now, right, we are constraining our domain. We are constraining our world domain, right, to GCT. So now we are referring to all the students, right? Now we are referring to the properties and methods, right, that is applicable only to GCT, only to a student who is studying in GCT. Okay, so GCT student, right, he is also a student, and every student is also a person, right? So here, right, I can go and define, for example, right, whatever the specific properties and methods that are applicable, right, only to a GCT. Okay, so here, right, I can add some more properties and some more methods, right, that is applicable only to GCT student. And again, right, if you want, right, from GCT student, I can define, right, something called as from GCT student, right, say a GCT E&I student, and then from again from GCT student, I can define a GCT ECE student. Now, right, so GCT E&I student, he is also a student. He is a GCT student, right? Okay, and then, right, GCT ECE student, he is also a GCT student. Okay, now, right, we will have specific properties and methods that are applicable only for an E&I student. Okay. And a GCT ECE student will have specific properties and methods that are applicable only for ECE student. Okay, for example, right, what are the subjects that a E&I student will study, and the number of credits that are applicable to that. The same subjects in the same, right, curriculum, it may not be studied by an ECE student, right? And the rules, right, that are for passing, right, passing a degree in E&I, right? So that may be different. The behavior may be different. Whereas, right, the behavior, right, that is exhibited by an EC student, it may be totally different. Okay. So now if we see, we are having a hierarchy, something like this. So now we are having a hierarchy, right? So this the super classes, we are having person. Okay. So we are having person. So from person, we are defining two classes, right? Two subclasses. One is student, right? So here we are having student, and another subclass we have is teacher. Now again, right, from student, we are defining one more a subclass which is called as GCT student. And from GCT student, right, we are defining two more, right, classes, subclasses, which is corresponding to E and I. And another subclass, right, corresponding to EC. Now, if you see, right, now this is a subclass of GCT student. This is a subclass of GCT student. GCT student is a subclass of student, and student is a subclass of person. Okay. Now, if you see what is the superclass, the superclass is person. Whatever the attributes that are present here, they are inherited here. And whatever the attributes that are present in student, they are inherited in GCT student. Whatever the attributes that are present in GCT student, they are inherited in E and I and ECs. Okay, so this is how, right, the information flows. Okay, and this is this modeling, right? So how we are defining this, it actually, right, it depends on your application. For example, right, if I am developing an application, if I'm developing a software only to handle GCT student, then there is no point in I can cut this entire hierarchy. I can start from GCT student, defining GCT student, and defining the students corresponding to each and every department. So that will be a very good move. Rather, why I want to have all the generic classes that are present inside the program. Okay, so it depends on it purely depends on your application. This class hierarchy, how you are defining them, right? It purely depends on what is the application that you are trying to write, what is the software that you are trying to write. So let us define, right, two students, right? So from student class, so it is having a constructor, right? As before, it is having an str function. And what are the data members that we have? We have a name of the student and we have a grade of a student. Okay. And then from student, we are defining one more a subclass of the student, which is called as student A. Okay. So student A is a subclass of student. How will you define a subclass? You have to say this is the class name, and then right within brackets, right within brackets, you have to say what is the superclass. So the superclass is student. Right. So this is a superclass subclass. Right now we have defined student A as a subclass of student. Okay. So similarly, right, we have another student called as student B. The student B is a subclass of student, right? So, so student A is also a subclass of student. Student B is also a subclass of student. Now, if you don't like A and B, right, you can define that as E and I and EC. Okay. And how, right, student A differs from student B? The student A, right, student is a superclass which defines to a very big group of students, and then student A is a subset of students. In that student class, we have a subset of students whose grade calculation, right, whose grade calculation it is different from a different subset of students, which is student B. So student B is a different set of students who are again present in that student class, right? But the grade calculation it is totally different. So for student B and student A, how they are different? Now, what are the attributes that are common for student A as well as student B? Attributes that are common for student A and student B is we have name, we have grade. Okay. And then the methods, right, that are common for student A and student B are this constructor method and this str method. Both are common for student A as well as student B. Okay, but what is the difference between student A and student B? So when you go for calculating the grade, given the same mark that is obtained by a person a person, right, that is obtained by a student A and versus the grade, right, that is obtained by a student B, how you are calculating the grade, that is going to differ. So if you see here, for student A, right, it is the same calculation. So grade is greater than 90, greater than equal to 90, we are going to return it as A. If it is greater than or equal to 80, we are going to return it as B, right? Any other number which is lesser than 80, so we are going to return it as C. Whereas, right, for student B, the class, right, the subclass student B, here we are going to calculate the grade something like, if the grade is greater than 70, we are going to have an S grade, and if the grade is greater than 50, and between 50 and 70, we are going to have an A plus, and then, right, if it is lesser than 50, we are going to have a F grade. If you see here the grades are ABC, whereas here the grades are S, A plus, and F. So both the grades are different. Okay, so the behavior that is being exhibited by student A, that is different from the behavior that is exhibited by student B. So how that behavior, which behavior is different, this calculation grade is different. Okay, so now, right, we are creating two students, right? So student A, for student A we are creating S1. So student A, right, we are creating a sample is Allison 90, whereas, right, student B we are having Bob is a student B, an object of student B, and with the marks 90. So both the marks are same. Alice is also, right, having marks as 90, and Bob is also having marks as 90. So now, right, we are printing the students. So we are printing the student and followed by what is the grade, right? So what is the grade that has been obtained by the student? Now, if you take S1, S1 is an object of student A. But if you take S2, S2 is an object of student B. Now, what is happening when you are calling student A of Alice, 90, right? So it will invoke the constructor of student A. Now, when you are calling student B of Bob, 90, it will invoke the constructor corresponding to student B. Now, let us go and see whether we have a constructor corresponding to this call in student A. So whether we are having a constructor here in student A, here we are not having the constructor. But, right, student A is a subclass of student. So if you go and see the student class, here we are having a constructor. Okay. So by using the constructor that is present in student class, the object of student A is initialized. So similarly, for student B also, right, we are not having any constructor here. Okay, but by using the constructor that is present in student class, because this is a subclass of student, all the methods and data members that are available in student, it is also available in student B. Okay, so by using the constructor that is present in student class, we are initializing an object of student. Okay, now, right, student A, S1 dot name will be Alice and S1 dot grade will be 90. S2 dot name will be Bob and S2 dot name will be S2 dot grade will be 90. Okay, so that we got here. Now, right, if you go and say say S1 dot calculate grade, what is happening? So it will write what is S1, what is the type of S1. The type of S1 is, it is an object of student A. So it will go to the class student A and it will check whether there is a method called as calculate grade. So in student A, there is a method called as calculate grade, and as a result, right, this method will get executed. Whatever the output that is produced here, that will be returned. Okay, now if you go and say S2 dot calculate, what is S2? S2 is an object of student B. It will go to the class student B. It will check whether there is a method called as calculate grade. Yes, there is a method called as calculate grade. So this method will get executed. Okay, so this calculate grade, it is different for this. It is written completely different for student B, and it is also written separately for student B. Okay, so depending on which object, right, you are passing this, right, on which object, right, it is being called. So if you are calling it with the S1, then the calculate grade that is present in S1 will be called. If you are calculating it, if you are calling it with respect to S2, then the student B, right, whatever the calculate grade present in student B, that will be called. Okay, so let us see, right, how whether this works. So we have created two objects, right? So this is S1 and this is S2. S1 is student A, S2 is student B, and here we are printing the object. So if you see here, the constructor that represents a student object that has been called, object has been initialized, and we are getting the output. The str function is called and it is printing the result. And then here we are having S1 dot calculate grade. The marks that are Alice and Bob both are getting the same mark, 90 and 90. Now if you go for S1 for Alice, 90 and 90, for Bob 90 and 90. Now if you go for S2, S1 dot calculate grade, the marks that are Alice and Bob both are getting the same mark, 90 and 90. Now if you go for S2, S1 dot calculate grade, the marks that are Alice and Bob both are getting the same mark, 90 and 90. Now if you go for S1 The calculate grade is 90. It is greater than or equal to 90, so it will return A. So we are getting a A grade for Alice, right? And what about for Bob, right? So if we go for a student calculate grade, so it will come here. It will go to the calculate grade present in student B, and then here, right? It is if it is greater than 70, 90 is greater than 70, so we will getting a S grade. So here we are getting an S grade. Okay. So this is how, right? We inherit subclasses of superclass, and then we use it. So any doubts you have, you can ask. We will stop here and we will continue tomorrow.